Hey everybody, today I'm going to show you a few tips and tricks on working with sediment core data in the software Dragonfly. So we're just going to import quickly some image data. So I'll go to File, Import Images. We're going to go to Add, and I've selected all of my processed XY planes here. And of course, there are a lot of them as we go down core. And this includes the index file. So what I'll do is I will just go Control A. That's going to select everything. We'll click Open. Some files are not added. Okay, that's just the index file. Wasn't a TIFF. Select OK. Go next. Here you can add the image spacing and the image sampling. We have something like 300 micron sampling both in the X, Y, and Z directions. So you can add that information if you want. I won't. Just go finish. This can take up to 10 minutes. But apparently it's going faster, which is awesome. Okay, and now we have a representation of our core in one panel here, and it is in the XY plane. So we're looking down at the top of the core. We can move this color bar out of the way. The first thing that I like to do is I go to the views and I choose the 3-panel view, and this is our three primary planes in the core. So this is our XY, our XZ, and our YZ planes. I'm just going to move these color bars down to the very bottom using the left click. Here in the Layers tab, we can see our core. I wonder if we can rename it. We probably can if we want to, but it's currently the not very descriptive 00000. Okay, let's go over to window leveling and make some first pass changes. So now this is a histogram of your pixel intensities in this image. Actually over the entire data set, not just what you're currently viewing. And this is the low density pixel intensity related to air. These are the moderate pixel intensities related to the PVC in the core barrel and also the mud. And that's what we're going to zoom in on. So we're just going to click and drag using a left click. All right, perfect. So now we sort of contrast stretch to the region that we're most interested in. If I want to pan and zoom around the image here, what I'll do is I'll use the rollerball on my mouse. I'll click and hold with the rollerball on my mouse, and I'll pull the mouse towards me in order to zoom in on the image. And I will left click and right click at the same time and hold in order to pan. So I'll do that again over here. We click the rollerball, and then we pan using a depress of the left and the right click on the external mouse. And I would highly recommend not doing this on a laptop touchpad. Okay, again, XY, XZ, YZ planes. The next thing that we're going to do is remove a little bit of the speckle noise that we see in this image. And we do that by changing from a sliced view, which is a single plane, to a statistic of a slab average. And so we can do that here by going to Scene Views, choose the window that we want to create a slab average for, and then instead of choosing slice, we go slab average. And you can see already some of that speckle noise has been removed, but we can go in, sort of drive using the XY plane, and we can make the region which it's averaging over thicker. And as you can see, as you do that, you start to get a sort of mushier image in the center here. So we'll choose a width of about 1 centimeter. And again, because I did not set our XYZ resolution, that's like some crazy number that's not actually realistic. Okay, cool. And if I wanted to steer through this XZ plane, what I would often do is just click and drag on the XY and move that set of crosshairs. Okay, cool. What else can I show you? You can change the color maps here by scrolling up. I think it's back in your window leveling tool. You can go, I think you use Inferno a lot, so we'll choose the Dragonfly option. That's sort of like that. Okay, and so now we've cleaned up that data quite nicely. You can see this was our original image, and this is how we've updated it. It's looking better. You can see those individual clasts in that cohesive debris flow. Super cool. And what can we do now? If you want to change the angle of your orthogonal slices, you can also do that in the XY plane over here. Let me show you how that's done. So here is our crosshairs, and we just click the triangle and we move that angle. So now I'll show you that. And you know what, let's just change this color map to something that doesn't match the color of the crosshairs so closely. Okay, so now we're in Viridis. And we just move that. You can see it rotating throughout the core. And some of these angles are going to be more useful than others, but it's nice to have those options, right? All right, cool. So that's that. Now, if you're happy with your view and you want to create a two-dimensional animation, what you can do is you can go down to the animation tab. You can select the number of slices that you want to pass through per second right here. That's your frames per second. And we'll select the plane that we want to pass through. And we can set the starting slice and the ending slice. So from here, let's start here. This is slice 0, and as you move up, you get about 950 slices in these CT scans. And so what I'll do is I'll just say, let's go from 300, slice number 300 should be about here, and we'll end at slice 600, which will be right about here. And so if you didn't want to look at all of this air, that's what you would do. And 80 frames per second is going to be pretty fast, but we'll just show you what that looks like. Alright, so here it is passing through the image automatically. And if you wanted to export that video or the series of pass-throughs, what you would do is you click stop and then you go to export and you can export to wherever you'd like. If you just want to export a screenshot of the currently selected view, the first thing that I would recommend doing is getting your crosshairs out of the way, and then you would go right click, export screenshot of view, and then you'd set the resolution. And you can set these to like banana resolutions if you want. This is a 10,000 pixel by 20,000 pixel image, which, you know, you will have to crop some of that out, and so maybe that ends up only being 4,000 or 5,000 pixels in the X direction. But in any case, you can make these relatively high resolution. Okay, so that is most of it for the two-dimensional plane. I typically only work in 2D or 3D at a given time. I don't do both. Okay, so now what we're going to do is we're going to move on to the three-dimensional view. Cool, so let's go back out here, drag this over here. Okay, so now we have our XY, XZ, YZ planes here. Awesome. And what are we going to do next? Well, first I'll show you what the three-dimensional view actually looks like. That, if you go to the 4-panel view, the three-dimensional panel will show up. There it is. We can double-click it to enter that view only. And the controls are roughly similar, so if you push your roller ball on your mouse and you push the mouse away from you, you can get that to zoom away. And then if you single-click and drag, you get to orbit that three-dimensional volume, and then I think pan is going to be the same, so it's a right click plus a left click at the same time, and then you drag. Okay, so those are your primary functions there. As you can see, the air in this three-dimensional volume is opaque, and so you don't see any portion of the core itself, and you can change that by using your window leveling tool. So, oopsie, I just popped that window out, annoying. And so now we're going to zoom in on just that region. You can see, oh, there's all the debris in this core. Wow. When you are working with your jumbo piston cores, I believe the plastic that you use is low enough density that it's often lower density than the mud itself, which means that you can effectively make that portion of the core transparent just using the window leveling tool. If you're using PVC, however, the PVC itself is going to be a higher density than the mud. So you can't remove the PVC using just the window leveling tool. You actually have to clip it out of the frame. And you can do that in the following way. So we're going to exit the three-dimensional view. We're going to go back to our two-dimensional view and zoom out. Now we're going to work in the XY plane for just a minute. So we're going to click the XY plane. We're going to scroll down. We're going to create a cylinder. Okay, so now we've created a cylinder. We see it in all 4 of our views here, and we actually see it in our layers tab as well. So we can turn that off and on. That is our cylinder. And we're going to make the cylinder just big enough to look at the mud. We're going to clip out that, where we're going with this is going to clip out the PVC barrel on the outside. You can see that right there. Okay, so now we have effectively a smaller radius cylinder inside. We're going to subcore our coring barrel digitally. Okay, so now what do we do? Now we're going to go here to our three-dimensional view, and we are going to say, we're going to select the cylinder, and we're going to clip our core imagery to our cylinder, and we're going to clip out the outside. We're only going to leave what's left on the inside. And these are the three options, or the five options that you have here. So we're going to use the clip function, and now as we update this, oh look, we have lost our air. All we see now is the core barrel itself. So now let's go back to just the three-dimensional view, and we're going to go like this. So this is the opacity mapping, and then this is the color mapping down here when you get to your three-dimensional visualization. Ooh, nice, looking better. Okay, okay. And so now, if we move our opacity mapping, we can see, okay, now we are only looking at our high density class, and everything less than a certain threshold has been removed altogether, but we still see the wireframe of our cylinder here, and so let's just toggle that off, so now we don't see it. Okay, so now if you wanted to like export some three-dimensional either screenshot or movie from this feature, I would say the first thing that you should do is get the visualization that you want. Like maybe you don't want this, you want this instead. And let's opacity map this here and here. And now let's actually select that again. Can we do that? Let's see. Well, probably a way to change this color map, but I'm not going to play with it for the time being. Okay, cool. So you have your image. And now what? Now we're going to go off to our left toolbars here, and I'm going to go Scene View Properties, click the three dots in the background color. We want a uniform white background, so we're going to do that. Okay, okay, nice. Now we have white only. And then we are going to right click and we are going to do Show Movie Maker, and that'll open up a toolbar on the very bottom here. And this basically works on the concept of keyframes, and I won't explain that here. It's a sort of a basic interpolation technique for three-dimensional objects. Basically, you have a timeline of a 30-second movie right here, and this green bar is like wherever you are in time in that movie. So let's select 5 seconds into the future, and let's zoom into and pan up to, let's see, ooh, look at that little shell right there. And then we're going to add a key. And what this does is it just linearly interpolates from point A to point B on your timeline here. So we can click and drag this time feature, and ooh, yeah, we can see that. Okay, cool. So we can do that, and for every keyframe, you can change whatever you want. Like you can also change the visualization, but not the position in this as well. So now you can you could do something like this. I don't know why you'd want to do this. It doesn't look very good. But you can like change the color mapping, and then you can add a key. And you can see what that would look like here. We can just click play. So now it faded to that new color mapping. And let's go here. And let's change that to a more useful color mapping again. Let's go back. Yeah, let's go back to that. Zoom to a new place in the core. Okay, and then let's add that key again. And then you can also add a rotation keyframe. And so if you've lined this up perfectly, and I have not, if you've lined this core up on a given axis, let's say the z-axis, right? You often want to rotate this on the z-axis. Let's just add a key right here really quick. You can now rotate along those axes. And let's click that. Yeah. And then it will automatically rotate that 360 degrees for you. So that is one way for you to make a pretty cool multi-stage video of your three-dimensional data. When you're done with that, what you can do is just click export, export that animation at whatever frame per second that you need, and also whatever video dimension you need. Okay, so let's save this as a video file, and we'll just look at the final product in a second. Let's save it as downloads, perfect, and let's call this test video. And it's going to save as an API. This can be pretty intense on your graphics card. So depending on the computer resources that you have, this can take quite a long time. This is a pretty simple video at a coarse resolution, and we're working with a decent graphics card here as well. So it shouldn't take too long. Each frame renders as it exports. This core is from 1,100 meters water depth in Astoria Canyon, and it's right below the sort of Big Ears Scarp after it makes that left-hand turn downslope. After the canyon makes that left-hand turn downslope. All right, cool. So we just exported, and we will go to our downloads now. Look at our downloads, test video, and we can watch it. We can play it back. And so we might say like, oh, I think we should up the resolution, blah, blah, blah. And you can iterate pretty quickly on the appropriate video that you need. And you can go longer than 30 seconds if you want to. That is not a problem. Okay, cool. I feel like that is enough to get you started for now. And if you have any questions and they pop up along the way, do let me know. Happy to help.